Webinar on Unlocking Industry 4.0, Mastering the Asset Administration Shell Modeling. So my name is Filipa, and I'll be moderating this session today. And before we begin, I'd just like to discuss a few notes. So first of all, this session will be recorded, and the recording should start now. Perfect. And also, to ensure the best experience, I would ask you to please keep your microphones and cameras turned off during the presentation. And by the end of this session, we'll have a Q&A session at the end. So you can place your questions there at any times during the meantime. If you want to place some questions on the chat, that is available to you. And today we'll have Emilio. Emilio will be presenting this webinar. And Emilio joined AIMEN in 2016 as a part of the factory automation team within the Smart Systems and Smart Manufacturing Group. Emilio holds a master's degree in industrial engineering from the University of Vigo, and his work is focused on the development and implementation of the asset administration shell, contributing to several European research and innovation projects in the field of Industry 4.0 and digital manufacturing. So, Emilio, the floor is yours. Whenever you want.
Thank you, Filipa. So let's start with this webinar that is focused on the asset administration shell. The idea is to explain what it is, its structure, and how to use them, and how to create one from scratch. So the plan for today is to start with a brief introduction of the AAS and some practical applications, and then we will go deep dive into the structure of the AAS itself. And finally, a little bit about the role of IDTA and standards and tools that can be used. Then we will go a little in practice, and I will create an AAS and register them. And finally, as Filipa said, we have a Q&A at the end. So let's start. What is an asset administration shell? An asset administration shell is a standardized digital representation of an asset. And we understand an asset as anything that has an added value to a factory, to a company. So it can be a lot of different things in the scope of Industry 4.0. It can represent a factory, equipment, products, different processes, a lot of things that, as I mentioned, add some value to our company. The idea of the AAS is to turn these assets into digitally manageable assets, so we can work with them in the digital world and establish its relationships. And so implementing the digital twin using this method. The main objective is to provide interoperability, especially between software applications. So regarding these objectives, there are a lot of things that the asset administration shell aims to be used on, starting with, as I mentioned, interoperability. In one hand, we can understand it as a cross-company interoperability. So in Industry 4.0, we have a lot of different companies that participate in the production of a product, and all these companies need to communicate between themselves and share information, and this is a way to make this process more interoperable. We also need this interoperability between different solutions, between software solutions that can interact with each other. We also can use it both for non-intelligent products and for intelligent products. We understand non-intelligent products as those types of assets that don't have the capability to communicate or to exchange information in the digital world, so everything that doesn't have a communication, but we can model them to exchange this information and work with them. And also, of course, we can model intelligent products as well. The aim of the AAS is to cover the complete life cycle of the product, products or machines, since the beginning to the end of the manufacturing cycle, enabling this way integrated value chains because, as I mentioned, the value chain is scattered among different companies, and we need to make communication information between them. It can also be used as a base of autonomous systems and artificial intelligence, and also to aid in plug and produce manufacturing and modular production. Here we have a diagram that is used to explain all the dimensions in which a digital twin can be applied. That covers all the life cycle phases. It also works in different hierarchical levels and have different uses, because maybe we want just to digitize and visualize information, but we can also want to simulate, to predict information, or to extract information from the twin. So the idea of the aim of the asset administration shell is to be able to work in all of these dimensions, and also to integrate some of them and make communication between them. So now that we spoke a little bit about the general terms of asset administration shell, let's talk a little more specific about the AAS itself. So because the AAS aims to cover the whole life cycle of a product, we need to make a distinction between what we understand as an asset type and as an asset instance. An asset types is the representation of a model of the asset that we want to model. So, for example, if we are speaking about a machine, a robot, a specific robot model, we would have an asset type that describes its characteristics. It could describe the reach of the arm, the number of axes, the power, and all these characteristics of this type of model would be the explanation of the asset type. And when we purchase a specific robot, or when we have one in our premises, we would instantiate this asset type to create an instance of that asset. So we would have an asset instance specifically for the robot that we have. The same can be applied, for example, if we're speaking about products to be manufactured. If we have a product, we would have a product type that describes maybe its dimensions with a CAD. We can also have information about the processes that we need to manufacture this product, and all this would be the product type. And then when we start to manufacture, for each new part that is going to be manufactured, we'll have an instance of the product with the specific information of that product, the specific processes that it really went on, and the tolerances that it had, and et cetera, et cetera. So we need to make that distinction. Furthermore, the AAS is comprised of different submodels. These submodels contain all the characteristics and features that we want to add to the asset. It could be features, it could be variables that we are measuring, it could be parameters that we want to configure, a lot of things. For example, here we have an example extracted for the Quick Start Guide of Asset Administration Shell that represents a servo motor that we have. And it can have different submodels. For example, it could have a submodel regarding identification that just have general information like the manufacturer of the asset. We could have a technical data submodel that deals with specific features or characteristics of the motor, for example, the maximum rotation speed that it can work on. We could also have operational data. This is data that we are measuring in real life data of the robot, or the motor. For example, the rotation speed that it has, or the torque. Finally, as an example, we could have a documentation submodel that gathers all the documents that are important or relevant to the motor, like, for example, the manual or the security instructions or anything like that. So this could be a general example of how we understand an asset and its representation in asset administration shell. The AAS can also have be of different types, depending on the use that we want to give this AAS. The first one is used just to share information. So if a partner has information about an asset, it can model the asset in AAS, store it or save it in a file, and share this information using this file. So this file exchange would be the first type of AAS. We would also can have type 2 that represents interacting with this AAS. For example, if we want to extract information, some parameters that are stored in the AAS, or if we want to update live data in the AAS, this type of exchange of information with the AAS would be type 2. And to use this type 2, we would need to configure an API to interact with the AAS. And finally, we would have the type 3, which is a specific type that deals with the interaction between an asset administration shell and another AAS. So it's a peer-to-peer interaction between AASs to negotiate between them and reach a specific end. To make this possible, it's needed to use a specific common language between them, which is referred to as an I4.0 language. So the communication is understandable. And also each AAS needs to have a software or an active element that makes this communication possible. Besides this fair introduction to the AES, let's take a look to real use cases that we can have the AES used for. Here in these few slides, I put the different use cases, some of them, of course, there are not all of them, and some European projects that we as AIMEN are working using as an administration shell to achieve these goals. Most of these projects are not finished, so in some of them we are still working on these types of cases, but some of them are. The first case, which is the most general one, is to store information in a standardized way. So standardized information of an asset. This could be used, for example, if we are a manufacturing company and we are selling some type of machine, we can have AASs for the different models of our machines, and with all the configuration and specification parts and technical data. So our customers would have the information of our products in a standardized way, so they would know where to find each specific information, and also they could even configure some software to compare one product to another, and also even to configure this machine previously to purchasing the machine. So it would be make this process easier. This type of standardized information was used in most of the European projects because it's the first step to standardized information. For example, in Operatic was one of the main ones because it was dealing with modeling a lot of different machines, so a standard structure was needed, but in all projects was mostly used. The second point is similar, is also dealing with standardized information, but regarding exchange of data. So what we spoke about before in the type 2, this exchange of data, it can be configured in the AAS, so we can update data in the AAS and also extract information regardless of the IoT protocol that we want to use. And this was also applicable in most projects because most of them had information that we want to update or extract. But for example, in Pioneer and our R3 group, we had this type of machines that we were updating data from. Another use is to use it in reconfigurability and interoperability for plug and produce and modular scenarios. This was applied, for example, in the DemoFact project, where we have a lot of different production line with a lot of different machines, and we have AAS that model those machines and the capabilities of each machine. So software was able to, when we wanted to fabricate, manufacture a new product, was able to choose which machine was able to do those processes and select them based also on availability. Other cases are, for example, to model different types of modeling schemas like the PPR, product, process, and resources related to the capability, skill, and services model, and also to model some main Industry 4.0 components like the digital product passport. All of this was done, for example, in the Da Capo project. Other things are, for example, when I spoke before about the type 3 that allowed communication between AASs, this can be used to allow negotiations between assets and therefore between companies, because we can model those companies as AASs of type 3, and then they can communicate between each other and reach specific goals. For example, if we have a company that needs to purchase some material and a company that gives this material, they can communicate between each other using AAS type 3 and reach a specific smart contract between them to purchase this material. This is being developed, for example, in the Maestro project. And finally, regarding the CONVERGING project, which this webinar is a part of, we are modeling not only machines, but also human operators. So in this way, we can establish interconnection between them and share information about them. And also we have different software modules here that we need to communicate between each other. So we do that also modeling these software modules using AAS. So these are a general introduction that I just made and some use cases. And now we are going to deep dive into the structure of the AAS itself. So first of all, I need to mention the Industrial Digital Twin Association, which is the consortium of companies that has developed the AAS and also supports the development of asset administration shell in different use cases. And it does this using its platform that I linked here. And there you would find a lot of different documents. And also you could find the explanation of the structure and the semantics and all the information that you need to model an asset administration shell and its components. And all this information is gathered in the AAS specifications, which are these 4 documents that appear here and that I also linked to the IDTA platform. These 4 different documents, each one details a different part. The first one is a document that explains the meta model, so how to process and structure the information of the AAS. And another things like identification that we use or some things like that. This first document that deals with the structure is the one that we are going to talk about the most here, because this presentation is based on this document, because we are going to go in depth in the structure of the AAS and look at each of the super elements that made the AAS and explain them. So this is all explained in this document. But there are other ones that are also very useful in the specific cases. The second one is regarding the application programming interfaces, so the APIs. When I spoke about the AES type 2, when you need to interact with the AES and change information in the AES and also extract information, you would need an API to interact with it. So this document explains how to program this API and how the queries need to be, etc. So this is what this document is for. The third document regards semantic information, how to add semantic information to our properties. And finally, the last document deals with a specific package file format. So the file that is used to save the AAS information is a specific file, the AASX, and this document just details how it is formatted and how it is used. But as I mentioned, we are going to be focused on the first document, and so let's go ahead and speak about the meta model of the asset administration shell. The first version of this meta model was around 2018 published, and now we are already in version 3, which I think from 2020 or something like that. The AAS implements a generic standardized interface to manage all the asset information, and this is what we are speak about when we talk about the meta model. is usually represented using a UML class diagram that explains the structure of the AAS. For example, we have here the asset administration shell, and inside we have different submodels that comprise them, and also each submodel has different elements inside that model the different characteristics. And we are going to see this later. Also, when we define when we create a specific AAS, we can also export or create this type of diagrams to explain the structure of our own AAS. These AASs can be stored and saved using different serializations. We could save them as XML or JSON or another type. But as I just mentioned, there's also a specific type file that uses AAS, that is the AAS package container, that includes an XML or JSON file with information, but also allows to include different documents like PDFs or images, and in this way, all is contained in the same file. Going a little bit more in depth, each asset administration shell represents only one asset, and this asset or this AAS needs to be uniquely identifiable. This is because, of course, if we have a lot of different AASs in the same server or registry, we need to be able to identify each one of them. But not only the AAS needs to be uniquely identifiable, also the asset administration shell submodels and other components of the AAS need to be globally uniquely identifiable. Other elements, if we go down the tree of the asset administration shell, other more specific elements just need to be local identifiable in their space. So speaking about these identifiers in the document, there are a lot. There are a specific section that details how to use these IDs. We could use IRDIS or we could use IRI, which it could be URIs or URLs, but also is allowed to use custom identification if we have in our company proprietary identifiers or something that we want to use in-house. We can also use these custom IDs for our AASs. In the document, there is a table that you can check that explains for each element of the asset administration shell which identifier is recommended. Some is IRI, some is customs, DSOT, every different type. It explains which one is recommended and also says if this element needs to have, it's mandatory to have an identifier or not, because some elements don't need to have these identifiers. Also, there is in the Annex A of the document, there is also some examples. If you want to create your own AASs, there is some example of how to create these URIs to identify your asset administration shell. There are two main needs for these IDs. One is, as I mentioned, to distinguish between different AASs and its components. And also, if we want to link to something external, usually, for example, if we want to add semantic information to a property, we need to link it using an identifier to this external dictionary that adds the semantic, for example. Moreover, as I mentioned, the AAS is composed of submodels, and these submodels that define specific information about the asset can be custom made. You can make your own specific submodels with information that you want, but there are also templates, standardized templates that we can use. These standardized templates I linked here to the IDTA platform, because IDTA is the one that, of course, supports and also develops these templates. So you can go here to check the templates, and then you can make your own instance of the template in your AASs. And going a little bit further down the line of the structure, the submodels are also made of submodel elements. And these elements are the ones that are really used to define and model each feature and characteristic of our assets. this is the thing what no one of we are going to focus more in the presentation, and then a little bit later we are going to go one by one explaining them. But first I wanted to mention that it's mandatory to have semantic information about each one of these elements. And this is because we need to distinguish and be clear of the information that we are sharing. For example, I'm going to explain a little semantics with very quick examples. For example, if we are modeling an asset administration shell and we have a property that we name Python, we need for someone who is checking this AAS to understand what we are referring to. If we just say that it's Python, it could be maybe the animal if we are in the biology field, but if we are in the computing field, it would probably be the programming language. So we would need to add the semantic information to say that the Python that we are referring to is the programming language, for example. And of course, this distinction is probably not going to happen when you are creating an AAS, because these are two different things, very different things. But there are some examples that are more concrete and specific, and it can happen when you are modeling a machine. For example, you could be naming the technical properties, and one of them could be the capacity, but you would need to differentiate, because it could be the volumetric capacity, but it could also just be electrical information. So you need semantic information to establish with what are we referring to when we are speaking here. And this semantic information can be added to the asset administration shell via two methods. Either we link it using an identifier, as I mentioned before. You just use the IDTA to an external dictionary, for example, the ECLAS dictionary or the IEC Common Data Dictionary. You can link them using an IDTA, or you can create a component of the asset administration shell that is called a concept description. And this component is used precisely to explain semantic information. So to add definition of a property, and also to add the units, if we are talking of a physical property, the units that is going to use, for example. Besides concept description, there is also another component called a qualifier that is also used to add added information, extra information about the property or element. Of course, I'm not going to go too in depth here, because there are a lot of information about this. You, of course, in the document can find more information about these components and how to use them. But I just wanted to put a couple of examples in the case that you start to create your own AESs or check the AESs created by other people, to understand what these concepts are. So for example, let's say we are creating a new product and we are creating the AAS model of this product. We could have a property defining the height of the product, and we would need a concept description that defines what we mean when we say height, and also what units are we going to use for the height, like millimeters, for example. And we could use the qualifier, for example, to establish in which phase of the life cycle process we are, meaning this height refers to the height in the design part of the product, and it doesn't refer to the height when we are measuring after production, for example. So you could use the qualifier in this way. Another common example is, for example, if we are checking a submodel template, let's say that we are going to the IDTA and we check the submodel template regarding nameplate. Nameplate is used to add manufacturing information about the asset. So for example, we want to add in this nameplate, the template, sorry, there is a property that is called the year of construction. So we would need that property, and we would add a concept description that defines that what we mean is the year this machine is built, for example. And also we could add the qualifier, or I should say the template usually has a qualifier that specifies that this property is mandatory or not. Some properties of a template could be mandatory to use, and some could be optional. And also, we could say that the multiplicity, that means the number of times that you could use this property, is only one. You could only have 1 year of construction. The machine could not have been built in 2 different years. But there are other properties that maybe can be used more than once. So you would use the qualifier in this way. I hope these few examples make it clear the uses that we can have for this type of concepts. But now that we have talked a little bit about this concept, let's go ahead and talk about all the submodel elements that appear in the asset administration shell, what they are, and how to use them. Of course, there are a lot of them, but we are going to go one by one and check each one. So let's start with the data elements. Data elements are those elements that are used to model informational data that we want in our asset, our AAS. So the first one is the most common one, the more used one, which is a property. A property is anything that has a value and a data type. So anything you can think of. For example, if we want to model a temperature that we're measuring in a process, this would be a property. The value would be the value of the measuring, in this case 50 degrees, for example, and the value type, because it has decimal numbers, in this case would be a float. All the data types that can be used, or the AAS supports, are also specified in the document. You can check them there. And I just put a notation here to remind that the units of the property are specified in a concept description, as we just seen. So we will have a temperature with 50 degrees, and it would be a float. Another data element would be the multi-language property. It's a type of property that is used just to add information. And to add this information in different languages. So, for example, let's say we want to add the country of origin of a manufacturer, and we would add in the value of this property, the multi-language property, the language that we're going to use, in this case English, and the value, Spain. We could add another language, or more than 2, for example, in Spanish, and say that this asset is from Spain. And this is the use of this MLP, the multi-language property. The next one is the range. The range is to explain the range of an element. For example, if we still speak about temperature, we can have a process that needs to be between a minimum and a maximum operating temperature. So we would use a range to establish this. We would say the value type as well, in this case an integer, and the minimum would be 40 degrees and the maximum 60 degrees. As I said, the value types supported are explained. And there are a lot of them, booleans, integers, and are all explained in the document. Besides these 3, we also have references. References are just used when you are describing, for example, an element in a submodel, to say that this element is related to another element in another submodel. So to refer to another submodel element, or to even refer to an external property outside of AAS. So you here just establish the reference. It's a reference that if it's external, it would have a specific format, but if it's an internal AAS submodel element, you would add the submodel that is a part of, and the property itself, or the tree of properties if it's a nested property. We also can add all different type of files to our document, like PDFs, for example, and you would add the path of the document and the content type. For example, as I mentioned, a PDF, but for example, an image, JSON, whatever you want. This, if you are using the format file that I explained before, the one specified in the specification part 5, the AASX, this document would be contained inside this file, the AASX file. So you would have everything in the same file, and this would just be the path inside the AASX. And finally, as data elements, we have a blob. Blob is to add source code, raw source code that we want to add in our AAS. So, for example, let's say you have a JSON message that that you are receiving from an MQTT broker or something like that, and you want to add how this message is structured in the JSON itself. So you could add this source code value and just add which content type, which type of code is this. So all of these properties are the data element properties, but of course, we also have some other elements that we can use. So first, we have relationship and annotated relationships, which are very similar and are used to establish, as the name itself says, a relationship between two elements. Of course, it can be two elements inside an AAS or between two AASs, but you could also refer to external information as well. If we're talking about AASs, for example, we could have, let's say we use the few examples that we already defined. We have a measuring temperature and we had an operating temperature range for a process. Well, we could say that this temperature that we measured in this property that is located in the operational data submodel is referring or is used to check if the operating range is correct. So this one is related to the operating temperature range that is located in the parameter submodel, for example. So this would be a way to use the relationship. Annotated relationship is exactly the same, but you could add more things. You could add another submodel elements like the ones we spoke about before, and you could add them here to add more information or more things that you want to say about this relationship. For example, just an example, I added here a multi-language property in English that just gives more information and says that if the process is outside the operating range, the material that we are using could break, for example. So you would add more information in this type of element. The next one, the entity, is used to describe assets, similar to the asset administration shelf itself. With entities, you describe other assets and are commonly used when you are describing subcomponents of an asset. Let's say we are talking about a manufacturing line, the whole manufacturing line, and we want to establish which assets are a part of this manufacturing line. Well, each one of them would be an entity. For example, a robot, another one would be a heat treatment machine, and all of these would be entities of the manufacturing line. Each of these entities could have its own AAS, and you would link it here, or it could just be co-managed by this first AAS. Both options are available in the entity type. And then after entities, we have capabilities. Capabilities relate to of course, to the capability, skill, and services modeling schema and explain the potential of an asset to achieve a specific goal. So what an asset can do, basically. So for example, if we have a robot that its capability could be to load parts. You could use this robot in this manufacturing line or in other manufacturing lines to load parts in a manufacturing line. The heat treatment machine, for example, could have the capability of tempering the parts, and you could use these capability elements to establish reconfigurability, for example, or a lot of different uses using it. If we go a little more along, I know there are a lot of them, but we are reaching the last ones. We have the events. These elements are probably the more complex ones in structure. They have a few different elements inside, but basically they are used to establish information about events. So for example, if you are checking a specific property, you are measuring this property and you want that when it reaches a threshold, you want to trigger an event and have a message with this event. So you could use this element for that type of example. Or if you have a software that needs a firmware update, this trigger this triggers an event when we need the update, and you could use this event for that. There are a lot of different things that you could add. For example, the message that you want to add, the direction of the event, all these type of things you could add using this submodel element. And because it's a more complex property and I don't have time to go really in depth, I linked here a white paper that was published just this month in May and is in the IDTA platform regarding specifically events, how to use them, and its structure. So you could check this out if you feel you need to use events for your use cases. And then we also have operations, which are this type of property that has inputs and outputs. So if you have a manufacturing operation that has a trigger as an input and a status, for example, the status the operation is running or is in manual state or anything like that as an output, you would do the operation, you could use the operation to establish this information. And the last two are collections, are composites of other elements. The first one is a submodel element collection, an SMC, and is used to make these complex elements that are made of different sub-elements to create them. So for example, let's say we are talking about the dimensions of a product. We would have a submodel collection that is called dimensions, and inside these submodel collections, we would have different elements. We could have properties regarding the length, the width, the height, and we could also add, for example, a file with the dimensional drawing. Because we have this type of composite elements, we can use semantic information and add it here with a concept description, for example, or a link to say that each time you use the dimensions model collection, it will always have three properties and a file. So as to establish the structure that you would use. So this is the use for the collections to make composites of different elements. And then you have the submodel element list, which is similar, but is used more for, as the name says, to define list. For example, let's say we are measuring the length of a product that we have manufactured, and we make different measurements. But these measurements, it doesn't matter the order or the timestamp of each of them. We just want to have a lot of measurements to establish a median value or something like that. So we would add a submodel element list. We would say that in this case, the order is not relevant. Which type of element compose this submodel element list, in this case properties, and which data type they have, in this case floats, for example. And each element in the submodel element list which contain a property with the value. So the first length measured 12.3, the second length measured 11.9, and so on and so forth. We can also use this submodel element list to create or to model multidimensional arrays. So different dimensions of arrays. So let's say we continue a little bit with this measuring example, but now we are measuring temperature, and we want to add the timestamp of this measurement to maybe then plot the measurements of something like that, or the process in itself is continuing in time and we want to measure in different points. So we can add a submodel element list that contains submodel element collections, and each collection would contain the value of the temperature and also the time stamp, and with the second element as well, and so on. We would continue to add the different measurements of the temperature. So this would be the use for collection and lists. And I know there were a lot of elements, but I hope it was clear how to use each one of them. And now that we have go a lot inside how the structure of the AAS itself is, I just wanted to mention a little bit more in general that, as I mentioned, an overview of IDTA. As I mentioned, IDTA is a consortium of different companies that was created inside the Industry 4.0 platform, and its main goal is to provide this support and this development of the asset administration shell to use as a digital twin for Industry 4.0. In this platform, you would find a lot of different documents. Besides the specifications, you could also find white papers like the events one that I just mentioned, which is this one. You would also find guides and different use cases that have been used for asset administration shell, and you could download all those type of documents. And I don't know if the most important thing, but one of the most important things that they provide are the templates that we need to use to model our asset administration shell. Here I put just a few examples, but there's one for carbon footprint, also digital nameplate, documentation, etc., etc. There are a lot of them. So you could go to the link here, which is the link to the submodel templates, and here you would find all of them and the status. Some of them are already published, some of them are still in development or in review, and you would find all the information here. Just later, or in a few minutes, when we start with the practice part, I will go to this web page to show you a little more how you could find information here. And finally, regarding this presentation, I just put here some standards and specifications that we use or are useful when creating asset administration shells. The first one is just the norm that describes the asset administration shell itself. We also have the specifications here linked, which we already explained, and the submodel templates. And there are also some other specifications or standards like this one here that deals with the language of I4.0 components that could be very useful or needed if you are working or think to work in asset administration shell type 3, and when you want to communicate between AASs and you need that common language. And beside these standards, we also have different tools, because I explained a lot about the structure, but you need a tool to create one and to use it. So there are a lot of different tools. This image is extracted from the Quick Start Guide provided by IDTA. Here's the link. And there are a lot of different tools for all the different uses that you need. So you have this image here to take as an example. And also in the IDTA platform, there is a section called the Solutions Hub that stores there all the different solutions that were created by different partners to work with the asset administration shells. I just link here a few specific ones. The Package Explorer, which is the one we are going to use in the practice section to create and edit the asset administration shell. The basics, the Eclipse basics that is used for a lot of different things, but we are going to use to register the AAS in a server. And finally, I also link the shell toolkit developed by us in AIMEN, which is used to edit, to create, and to manage, and also visualize the AASs. You can create them from there. You can have different workspaces to work with different AASs and in a same environment. So you could use it for that. It's true that now we are the one that is published is in version 2 of the meta model, but version 3 is already being developed and is in quite an advanced state in the development part. So soon we will have also the toolkit in version 3. And now that I have spoken a lot about all the different structures and things regarding asset administration shell, let's go ahead and go a little more hands-on, and I will create an AAS from scratch. To do this, I'm going to follow more or less this guide that is provided by IDTA, and it establishes different steps to create your own AAS. First of all, you will need to choose an asset that you want to model. You will need to choose the submodels that you want to use for the different characteristics and features that you want to model. You would have to model it, of course. You could validate it using different tools that are explained before. for example, the AES engine, or just checking in the Package Explorer the different errors that appear. And then finally, you would deploy an AAS server if you want to register this AAS there to have all the AASs in the same server. So this is what we are going to do now. So let's start. First of all, we have to choose the asset that we want to model. For this example, I wanted to use a real case that we used, and we are because this is regarding the Converging project, we are going to use the Converging project to model an asset. Here in this project, we have a pilot line, which is this one. There is a collaborative robot that collaborates with a human operator for a process. No? So here we are going to focus in this example in modeling the robot itself. There is also a model of the operator, a model of software modules, but here for the example, we will focus on the model of the robot. So let's go ahead. I'm going to leave the presentation now and start the modeling part. And for this, we will use the Package Explorer, as I mentioned, that I linked in the presentation. So we would open the Package Explorer and we would begin the modeling process. So let's begin. This Package Explorer can be used just to visualize AASs if you have AASs from other partners, and also to create one and edit them. So for edit, we need to click the edit part or Control E here, and then we would have the environment to create our AASs. First, I would like to mention that as you can see here, there are some, so the Package Explorer always provides with some messages, these red messages, to inform us that there are some things missing or there are some mandatory things in the meta model that you have not provided yet, or some things are not correctly done. So you would always need to check and have an eye checking this type of messages to see that you are being compliant with the meta model. This fair message that just says that we don't have any AASs, so let's create one. We would go to the environment and we would create our first AAS. We would add here, and you can see that it added an AAS and also an asset. The asset is the physical element that we are going to model. In this case, the robot, and the AAS is the model of that robot. So starting with the AAS, first of all, we would need to put the name that we are going to create. So let's say that we are creating the robot. These AASs need to have, as I mentioned in the presentation, a unique ID, because you need to be global to be able to identify them globally. So this ID is this one here, and the recommended ID for the AASs are URIs. In the document, as I mentioned, there are some examples, but also here is an example of how the format could be done. So we are going to follow this example, but with real data. So let's say this is an asset in AIMEN, which is our company, is an AAS. And also this robot is part of a pilot line, of course, and then we would put the name of this pilot line, which in this case is the XXL pilot factory. And inside this pilot factory, we are modeling the robot. This is the AAS, and here you have the asset information. That's, as you can see, is the same as clicking here, is the same information, but it's also put here below to make more easy the editing of this AAS. So this AAS asset information, you need to establish if it's a type of or an instance. This is the first thing that we spoke about at the beginning of the presentation. If this AAS is a type of or an instance, this asset, sorry. And this asset, because it's a real robot that we are modeling in a real pilot line, is a specific robot, is an instance of an asset, or an asset instance, better said. And the asset also needs a unique ID. So we would create this element And I'm just going to copy the ID of the robot and add it that this is the robot asset. So now if we take over changes, we already have our asset and our AAS information. Let's save this project because just in case I close the project without wanting to. So here you can save as, and here in the desktop, I'm going to save this version of the robot. As I mentioned, there is a specific type of file, which is the AASX, and this file is the one that allows us to add other documents like PDFs, for example, to our AAS. So I'm going to choose this one. But you could also just save it as information in an XML or a JSON between, among other things. So I'm going to save it. As you can see, I already have a robot version 2, which is the complete model of the robot that, of course, I'm not able to edit today all of it. So later I will show you the complete one. But now we are going to create the version 1, just the start of the robot. Now you can see that we have our AAS and our asset information. And now we need to start adding information. So let's start. And to start, we are going to start adding information. We need to create submodels. And this message sheet here says that you still don't have any submodels here. So let's add one. As I mentioned, we are not creating templates now. We are just creating a submodel from scratch. So we would need to create an instance submodel. I should say that the first step would be to think about the features that you want to model and check if there already exists a submodel template with that information structured. And we are going to do that later. But now let's say that for the first type of information we have checked and there was no template for this information. So let's create one from scratch. So because it's not a template and it's a new submodel of type instance, we would click this button here, and then it would create the submodel. As you can see, it creates two elements, and this is because the AAS and the submodels are stored and saved in different spaces and different registries. So the AAS only contains here ID references to the submodels. So this element here is just a reference to the real submodel with all the information, which is this one here. And also when you registered in a server, it always says on the one hand the AESs with the references, and in the other hand the submodels itself. So this means that here when we create the submodel, let's say we want to add general information about the identification of the model. So we're going to call this identification. These submodels need to have a unique ID as well, a globally unique ID, because they are stored, as I mentioned, separately from the AES. So their ID needs to be unique, and they can be used by different AASs. That is the reason that they are stored separately. So the format of the IDs is very similar because it's also a URI. So we are going to follow this example as before. We are going to say this is also from AIMEN. In this case, it's a submodel, an SM, and not an AAS, and is the identification submodel. It's the identification submodel, but it's a specific one, the one that we are using in the robot. So as well as the AAS is for the pilot factory, and it's the robot. And because this is a reference, this one here, this ID needs to match the ID of the actual submodel, which if you find here, this is just the reference, and this is the submodel, which is the information that is contained here. So this ID, I'm going to copy it, needs to be the same one as this ID. So now, if we save this information, the match would be made. Also, this is pre-made for you, but this submodel is an instance. If you were to model a template, you would need to change this here. So you could take over changes or just Control S, which is save. And if I do that, you see that the information was saved and the submodels match. If, for example, these IDs did not match and you and this submodel could not find a reference here, a message would appear saying you are missing a reference and we don't have the match done. But we do have it, so let's start to add real information. So let's say we want to say which type of AAS we are creating. So if we are following a PPR, for example, we have could be model a product, we could be model a process itself, or we could be model a specific equipment, which are called resources. So let's say that we want to say that. We would add a property. Here you have all the submodel elements. You see you have property, multi-language property, collections, and others. Others are all of them. These ones are just added here because are the most common ones, so to make it easier. But if you click other, every submodel that we explained appears here. So let's say we want to add a property. We would add a property. We need to add an ID sort. An ID sort here is a local identifier because submodel elements don't need to be globally identified, just identified inside its submodel. So it just needs a local identifier, which is the ID sort. I should mention that the ID sort has some constraints to the things you can add here, the symbols. So for example, well, this information is in the document of the meta model, of course, but if I add something that is not compliant and I click the property, a message would appear saying this ID sort is not, it can be used because it's not compliant with the meta model. And here it says that, for example, it cannot start with a number. You would need to check this information, but I'm going to say that this property is to establish the type of AES that we are working on. Here, there are a lot of information you can add, including semantic information. Here, you would add these links to the dictionaries that we talk about, or the concept description. You could create one, and it could be linked here. Also, you could add qualifiers, as we mentioned, and all of that information here. I'm not going to do that because it takes time, but I'm just going to add the value of the property itself. It is a string because it's just information, and we're going to say that this AAS is a resource. Okay, we already have our first property. Let's say we want to add more information, just a general description of the asset. So we could add a property, just a description, but we want to add it in different languages. So let's say we add a multi-language property. We add it here. We also need an ID sort, of course, and we're going to say that this is a description of the asset. If we go to the end, we could add the different values of the multi-language property. Let's say in English first, this asset is a collaborative robot that works with a human operator, for example. And we also want to add another language. I'm going to add Spanish because I don't speak other languages. So we would say this is a collaborative robot that works with a human operator. Yes. We would take over changes or Control S, as I mentioned before, and you would have added these two properties. We could add more, but let's say that our submodel is complete. And now we want to add information, but of a different type. Let's say we are going to gather information about the robot, real data information about the positions and velocities of the different components of the robot. So this information cannot be in the identification submodel because it's other type of information. It's data that we are gathering. So we are going to add another submodel. And let's say this submodel doesn't also have a template. So we would add another. We go to the AAS again, and we would create another submodel of kind instance. In this case would be the operational data submodel that we mentioned in some examples in the presentation. We would need to add the ID with the same format. I'm going to copy the identification one. Be careful when you do these things to not put things that you shouldn't put. And instead of operational identification is operational data. And as I mentioned before, this ID needs to match this one here. And of course, check that it's an instance submodel and everything is okay. So we Control S and we have our operational data. And now let's say we want to add this information of the position and velocity of the different parts of the robot. We would need, because this robot, this specific robot, which is an IVV robot, has 6 different joints, and each joint has its own velocity and its own position, and its own torque, and everything like that. So we would need to add this joint as a complex element that has different properties inside. So if you remember, when we want to add this type of complex element, we would add a submodel element collection, which is this one here, or you would find it here in other. But if you check here, you would see that it regards to the submodel element collection. So if I add it here, and this I would say that this is the collection of the joint, the first joint, the joint 1. There's nothing more to add here except, of course, semantic information if you when you need to do that. So we would add the joint, and then inside this joint we would add the other elements. In this case, properties. So I would add a property, and I would say this is a position. And this position, because it's an actual measurement, an actual number, it's not a string, is, for example, a float, because it has decimal numbers. Here you can see all the different data types that we can have. So let's say it's a float, and the value, because it's going to be real data, live data value. For now, it doesn't have any value, but I'm going to say 0 for now. And this would be updated when we connect the robot with the AAS using AAS type 2. So now I have a position, I could add velocity, I could add torque, I could add all the other ones, and then I would be able to add the different joints. Let's say I've already done that. I have all this submodel completed. And now I want to add information about the different components of the robot. The robot is composed of all different things, the robot itself, but also a controller, and also it has a workpiece positioner, for example, to put something there. It has a tool, it has different things. So we need to add these components. To do that, we would need to add a submodel with this information. And I know that there is a template for this submodel. Of course, if you are starting and you don't know, you would need to go to the IDTA and check all the submodels that exist and if it applies or not to your case. So let's do that. We would go to the, I have a lot of things open here. Let's go to the IDTA web, which is this one. And you see here a lot of the different sections that I already mentioned. Here in the Solutions Hub is where you would find the tools and the different tools to use AAS. Here in the Content Hub, you have different downloads of documents like the white paper for events, for example. You have the forest specifications, and then you would have a template, the templates. You could also create new templates if you want to participate in that. But here we have all the templates that are already created or in review. Right now there are 98, so a lot of them, and some of them, as I mentioned, are published, some are in review, and all of that. Let's say that we want to find something. You could go one by one, or you could search. I'm going to go to the bill of materials one that I know its name, so it's easy for me. It's called the hierarchical structure enabled on bill of materials. So this is the submodel that allows us to establish a structure in the case of bill of materials to establish the different components. So here we can download the PDF that explains how this submodel works. So here in all of these documents, there is always here an UML diagram that explains the structure of this submodel, and there's also tables with each element of the submodel, a definition and how this submodel is used, if this element is mandatory or not. All that information that is important for this submodel to work is in this document. Besides the document, we also have a link to a GitHub. This link goes to the GitHub, and here, for example, in this submodel, there are 2 versions. In the latest version, you always have also the PDF is also here, but you also have an AASX file with the template. So here you could download this. I already downloaded. If I open it, I have it here with the PDF and the AAS. And if I open it, I would have here this template. As you see, it's a template. This is the symbol here, is of kind template. And here you would find all elements. In this case, there are entities that are composed of different entities because it's a composite of bill of materials. And here you would also find semantic information. You can find here, for example, the qualifiers and the example that I mentioned, saying if it's mandatory or not, and the value type, for example. And then you could import this template to your own AAS or copy and paste to your own AAS and work creating there from there. So let's say we have done all that with all the submodel templates that we want, and we have now our full robot created, which is not this one, is this one here. Now we have our full robot template here with all the submodels, the ones that you already know, the identification one with information, operational data with all the joints and all the properties, the bill of materials that I mentioned with the robot and its parts, and there's some other ones. The nameplate, we talk about manufacturing information, capabilities, also documentation that contains, here you would find the files, the digital file of the document that you have here. And also, I want to mention that before I didn't have units for the position when I created the property because I didn't have a concept description linked. But in this case, I do have one. Here in the semantic information, you can see that there is a link, and this link is to this concept description here of the position that contains here at the end information, the definition of what this position means, and also the units that we are going to use, different elements here. So now that we have our robot AES, the modeling part would be end. We could validate this using a tool or check as we go along. We could register this AAS in a specific server or registry. I'm going to do that as an example. And as an example, I'm going to use, as I mentioned, the Eclipse Basics software and the one that we have deployed in the Converging project. So if I go to the one of the Converging project, which is this one here, this is the basics interface for the server. You can see that I already have some ASs here from the project, like the operator one, and I'm going to add a new one. So here I could just drag the file here or add it via this button, and I'm going to add the version 2, which is the complete version of the robot. I add it and I upload, and everything went well. So I have it now here. There is here you can edit some things, and you can also have a special visualization that Basics provides. Specifically, if you use custom submodels, it's a common view that just has the properties with the elements. If I go to the operational data, it also has the units because it has an environment that stores also the concept descriptions, and I have the link here. But also Basics also have develop custom visualizations when you use templates that are already known. So for example, if you go to the bill of materials template, here you have it as a diagram that explains the different parts. If you go to the nameplate, you would have different information, and also adds the logo and adds a localization map to know where the manufacturer is. If you go to the documentation, you can even check the file, and you can even download the file from here without having to download the whole AES, and so on and so forth. So this would be the end of our hands-on practice. Of course, once you have the AES here, you could work with it using different software to extract information from the AES or update information or other things that you have in mind to use the AES. But now I'm going to go back to the presentation. I'm going to put this here to check you. And if I go back to the presentation, we have reached the end of the presentation, and here we have reached the Q&A. And thank you very much.
Thank you so much, Emilio. This was a very clear, very thorough presentation. I really enjoyed it. And I guess that now the floor is open for some questions. So I believe that anyone who wants to make a question can either put it on the chat or unmute yourself and ask it directly. And in the QR code, you can get the a short questionnaire about this webinar, which I believe I can also paste it on the chat. Yes. So for all of you attending, if you can give your opinion on this webinar, that is very important to us. And yes, we're open to questions. Maybe I can start with one. So Emilio, so what is needed if you want to update the values of the AASs in real time?
If you, for example, have the AES stored in the basics server, as we have done in the practice, you could Basics provides a component that is called the data bridge that allows you to configure this communication. So you will need, first of all, an external server. For example, it could be an MQTT broker or an OPC UA server to send the information. And then with the data bridge, you would configure the mapping from this server to each property of the AAS, and in this way you would update the AASs through the data bridge component.
Okay, got it. Any other questions?
I explain myself too well.
It was very clear, to be honest. I am not. I don't have the technical profile, and I could follow through your presentation. It felt very clear on all the steps. So I think that you were very clear. I think it's more that rather than people didn't understand you. Okay, if there are no more questions, I will just ask once again if you could fill in the questionnaire that is on your screens and also in the chat, the form about this webinar. This is very important to us, so please, if you can contribute here. And if there are no more questions, I believe that we can leave it here. And I would like to thank you, Emilio, for this webinar and all of your work here. It was really interesting to follow. And I guess that we'll see you soon, and have a nice rest of the day.
Thank you, everybody.
Thank you all. Bye-bye.
Bye.